Here is a word that you have probably heard many times, seen many times, and used many times. And as with many other similar words that we have encountered in this course, we need to clarify a little bit what it means. Okay? So the first thing to be said about correlation is that it is something that we analyze between two numerical variables, right? You see here a scatter plot. We're going to shortly see the importance of scatter plots in correlation analysis. But the first thing you notice about a scatter plot is that it involves two variables. There is one variable on the x-axis, usually it is the what we consider the independent variable, and then there is going to be a variable on the y-axis which we consider as the dependent variable. Moreover, these two variables are assumed to be numerical. Certainly we don't want to look at correlation between two nominal variables. Occasionally people use correlation to look at the relationship between two ordinal variables, or maybe between a numerical variable and an ordinal variable. That's okay in most situations, in many situations I should say, but it needs to be analyzed and checked each time. Okay, so always be wary when you say correlation being done between two ordinal variables or in situations involving ordinal variables. The other thing to be said about correlation is that it is usually done together with regression, which is going to be the topic of the last class. Both of them, in fact, both correlation and regression look at relationship among variables. Regression can also look at relationships among several variables, but they'll look at relationships, and they all require technically the use of numerical variables. Also, both of them use methods with many requirements that must be checked. You remember all the big issue of requirements when it comes to hypothesis testing, and of course that can be extended to any statistical technique. In particular, correlation and regression have some basic requirements which are often neglected or ignored, and that I'm going to focus on in this class and the next one on regression. So always make sure that those requirements are checked and that they're satisfied. Finally, keep in mind that although correlation and regression are often used together, they're not the same thing. They're in fact different techniques that address different questions, as I'm going to explain in a minute, and therefore they should be really looked at separately. There is a tendency to conflate the two and put them automatically together when in fact they shouldn't be. So let's see how the two in fact are different from each other. So how are correlation and regression different from each other, even though they are related in the sense that they both look at the relationship between two variables? Well, here is what each of them actually does. In correlation, we address this question, and the question is, are these two variables linearly related? You can smell that behind this question there is a hypothesis test question. Is it true that these two variables are linearly related? Notice that I have underlined the word linearly because that is one of the most important aspects of usual correlation and regression analysis that people often forget. If you look at this scatter plot, you can tell that there is a relationship between these two variables, whatever they are, and that this relationship exhibits itself through a linear pattern. The dots are scattered along some kind of a straight line. So you can tell that the line sort of goes like this. Now this is not quite a line, but you know what I mean, right? Actually, the fact that it is not a line, what I'm drawing, is something that we should be keeping in mind, because in fact in correlation and regression we do assume that that pattern, that connection is straight, is linear. So beyond this technicality about the requirement that the relationship be linear, that what we are focusing on are linear relationship, remember that the correlation addresses an is it true kind of question. On the other hand, in regression, we're addressing a different kind of question, namely the question of which formula describes the linear relationship, so now I'm drawing a better line, that we have checked to exist between these two variables. So this is more of an estimation question, right? So we're not asking so much is it true that, but which one is it? Therefore, the two questions are different in scope. They're different in methodologies, although they are related and one depends on the other, but they should be kept separately.